Hey, welcome back. This is a special edition of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. I want to do a quick little video on the transformations of functions using this tree table that I came up with um, towards the end of the chapter. Transformations of functions was covered on 3.6, and of course we see it again in 3.7 with the absolute values. But I wanted to use this tree table in the video, so I'll have it forever now on the internet. And what this tree table does is asks what is being modified, either the output, which is the f of x, or the y value, or the input, the x. So, we have ordered pairs, and this would be x, and this would be y. So if you're modifying the output, there's three things that we do to that output: multiply, add, or subtract. And if we multiply, there's three types of numbers that we multiply by. So we multiply by a -1, that's reflected in the x-axis. We multiply by a fraction, it's a vertical shrink by a factor of whatever that fraction is. And if we multiply by a number greater than 1, it's a vertical stretch by a factor of whatever that number is. And that makes sense. So stretch kind of means to be made longer or larger. So if we multiply by a number greater than 1, then that y value is going to get larger. And if we multiply by a number that's a fraction, that y value is going to get smaller. It's going to shrink. So those things make sense. Like I said, this is the side of the chart that makes sense. If we add to that output, that y value is going to increase, so the graph is going to move up by n units, whatever we add to it. And if we subtract n from it, well, the whole graph is going to translate down by n units, because down, well, means to be made less. Now, let's talk about the bizarro side. This is the bizarro side, where everything is kind of backwards of what you think, so you have to think twice when you're dealing with the input. So we can multiply, add, or subtract again. But now the thing that is kind of normal is multiplying by -1. Now this is a reflection in the y-axis. So anything that was on the positive x side now goes on the negative x side. So it flips kind of like you're turning pages in a book. You're turning from right to left or left to right. Multiply by a fraction. Well, you're going to basically stretch it horizontally by a factor of 1 over n. So if it was 1/2, now that factor becomes 2. The inverse of 1/2 is 2. So that's how it becomes a stretch. And if it's a number greater than 1, it actually shrinks it horizontally. It's going to kind of like compress it inwards from side to side. And if it was 2, if you're multiplying by 2, that input by 2, well, that factor becomes 1/2, right? The inverses of those things. When we add, normally when we add on a number line, we think that we go to the right, but now if we add to that input, it's going to translate to the left by that many units. And conversely, if we subtract from x, which would normally make the x value smaller, we're going to translate to the right. Okay, so let me do a quick example here of how to use this table. Okay, so here are two functions. F of x is the one we're starting with. It's 2 of x. And h of x is 6x minus 5. So the question is, describe the translations between f of x to h of x. Okay, so f of x is this first output. 2 of x, we're dealing with this input here. X is the input. It's being multiplied by 2. Now over here, that input is being multiplied by 6. So what happened to get from 2 to 6? Well, we're multiplying that input by 3. Okay, we're multiplying that input by 3. To get from 2 to 6, it's an input of 3. So we multiply the input, multiply by 3, which is a number greater than 1. So the first thing we have is a horizontal shrink, and the factor is 1/3. Okay, and then to that output, we're subtracting 5. Okay, now we're subtracting 5 from the output. Um, so the output here is on the left side. So we go down to subtraction, and it's a vertical translation down by 5 units. So vertical translation down. And that's it. That's how you would use this table. Okay, so anyways, hope this helps. That sums up, basically, this is the end of chapter 3 for us. Thanks a lot. Have a great rest of your day.